welcome. We will continue this chapter, which is the very high level overview. The analogy I gave last time was something like a helicopter tour over Hawaii, only much less fun. It gives you a big overview of everything that has to do with programming concepts, basic scripting concepts, and then specifically also what those look like in Lua. So Boolean algebra also uses variables, also uses these symbols, and uses them to evaluate essentially truth or falsehood. So the result of a Boolean condition, a Boolean expression, is a true or a false. That is sometimes a little confusing to beginning programmers because Boolean algebra looks very math-like. For instance, if I had a variable called boil timer, and I wanted to see whether its value was greater than or equal to 90, I might write the expression something like this: boil timer greater than or equal 90. And that does look a lot like math. You have a variable, you see an equal sign, and you see a number. And so some people will think, okay, the result of that is some sort of number. The result is the result of some sort of regular math, and it's not. The result of this Boolean expression is simply true or false. It has to be either true or false. The result of any Boolean condition that you write is true or false. So boil timer either is greater than or equal to 90, or it's not. There is no other possible outcome. So then what do we do with the true or false? Why is that of interest? Well, normally in writing programs, we have to make decisions about what to do, what code makes sense to run. For instance, in the recipe at the beginning of the keynote, the beginning of the chapter, there is a boiling phase, a cooking phase that lasts for 90 minutes, I think. And so we might want to, if this program was, say, running some sort of an industrial kitchen machine of some sort, maybe during the boil, we have a heating element of some sort that runs, maybe other automated equipment like a stirrer of some sort. So and we're writing the program, we want to know how long the boil's taken and whether to turn the heat down or stop the stirrer or whatever the case may be. If we were writing this program that controlled this sort of industrial cooking apparatus, we would have to write a lot of these sort of evaluations to know what step we're on, to know what actions to take, what motors to activate or deactivate, what heating elements to activate or deactivate. You would figure all of that out by using these sorts of Boolean tests, like, is the boil timer greater than 90 or not? If not, we keep the heating element on, we keep the stirrer on, we keep whatever else makes sense to be on for that stage. When it hits 90 or exceeds 90, then we change. We execute different code. We execute code that would shut down the heating element. We execute code that would maybe stop the stirrer or whatever made sense for whatever machinery you were controlling. It is these sorts of conditions that we would have to think through and write to determine what code executes to make the machinery do what we're programming it to do. The core way we do that is using something called an if-then statement. There are obviously if statements also in spreadsheets if your experience is more spreadsheet related. All languages have some form of a basic Boolean test, which is an if-then statement. The syntax in Lua is really simple. Use the keyword if, and then some sort of Boolean condition like that boil timer greater than or equal to 90 that we just saw. Use the keyword then, and then the keyword end to terminate the code that's inside of that chunk. So as an example, if we were controlling this industrial machinery and there was a function that we could call to turn off the stove, and it was called do shut off stove. I just made that up. Obviously, this is not an actual piece of industrial kitchen equipment. But if you assume that there is this function that would shut off the stove, and that's what it was called, then we could write this this bit of code, just like we have down here at the bottom, which is if bullet timer greater than or equal to 90, then do shut off stove. The code inside of the if statement is only executed for a true result of that Boolean expression. So if bullet timer greater than or equal to 90 ends up being true, you could also read that as if true, then do this. So if it's true, if what you asked is true, then shut off the stove. Otherwise, skip that. So code like this would probably be in on some sort of a timer that ran every second or however quickly you needed to run it. So it would be evaluated over and over and over again as the cooking process unfolded. And when it hit 90, then this do shut off stove will get called. So if you're coming from other languages, some differences, notice that there are no parentheses required around the Boolean condition. But Lua does require a then. So you'll notice there's no form of parentheses around the body of the if then statement. It is simply the inside of the if statement is between the keyword then to the keyword end. Everything between those two keywords is the body of the if statement. Any code that you want to execute, you put after the keyword then and before the keyword end. The other thing we use Boolean algebra to do is to determine the number of times we want to do something. So any sort of repetition will be controlled by Boolean algebra, where the truth or falsehood of the condition determines whether or not another repetition is done. So as an example, I've coded this using a repetition structure called a while loop that will repeatedly test the boil timer. So the while loop is an interesting loop in that, or it's kind of interesting that it looks just like the if statement you just saw, doesn't it? Except the keyword if is replaced with the keyword while. Otherwise, if you flip back to the previous slide, the syntax is the same. The while loop is sort of like a repeated if statement. You can think of it like an if statement that executes over and over and over again, except that the Boolean test determines whether the code inside of the while loop is executed or not, just like the if statement, but then it also determines whether or not you keep doing it. You need the inner parentheses because I want the not to hit the result of that condition, not to negate boil timer, as part of the statement. A function is just a named block or chunk of code that contains one or more statements. You execute or run or invoke a function by calling its name. There are functions that are built into Lua, and there are functions that are built into Solar 2D. There's also a palette of functions, a small number of functions that are built into drawing a code that you can add to your script stack. For any of these, they're called simply by naming the function that you want to call. Every language that you would learn is going to have some variation of this idea of a function. They're not always called functions. Lua calls them functions. In Java, they're called methods. Other languages call them procedures, stored procedures, routines, subroutines, and maybe more that I'm not thinking of. So in terms of the built-in functions, we often access them using a syntax that you'll see a lot of, which is we name a table, and then we type a period, and then we type the function that we want to call or invoke. So I call this the table.function syntax. This would be analogous in Java to the object.method. Lua is not object-oriented, but again, the syntax is very reminiscent of object-oriented syntaxes. So as an example, we will make pretty heavy use of a table that's built into Solar 2D called display. And inside of display, there are a variety of functions that we can call to put stuff on the device's display. You might have already pieced that together from the name. But so if we want to put text on the screen of our device, we'll use the new text function built into the display table. So you invoke it by saying display dot new text, and then sending some settings for the text inside the parentheses. And we'll get to the details of doing this later, but it's a super common one that we will use, and I'll switch over to drawing a code at some point. And we'll create some text, so you'll see it in action and see what the settings are that are involved in using it. In addition to being able to use all of the built-in functions, you also have the capability to make your own. So to some extent, that's where the real power is. In terms of breaking code up, making functions that carry out discrete tasks that are easily repeatable are ways to divide complex projects up. Also, it's a way to break work up among teams or among programmers. If you can break it into several functions, then you can hand out function assignments to teammates or whatever, and let them just focus on that little part of the code rather than the whole thing. The other thing I always say is, if you've programmed it all already, you probably know there will be temptations at some point to copy and paste your own code into another location. You'll get to the point where you realize, hey, wait a minute, I already wrote the code to do this. I can find it, I can copy it, I can paste it here and just reuse it and not have to type it again. It's a really common thing that happens, and what I would say is, if you find yourself thinking that should be a little bit of a red flag. Copying and pasting is almost always the wrong thing to do. There are a variety of reasons. Problem is, what happens when you need to make changes to the code you're copying and pasting? What happens when you realize you really needed to do one more step, or you need to edit it to fix an issue, or the code you've pasted also has a font and now you're changing the font to something else? Well, if you've cut and pasted this code over and over in your script, then you've got to hunt down all the locations where you pasted it and fix every single location. So that's just an invitation for making mistakes. It's an invitation for introducing bugs to your code. The much more elegant and easier way to do it is not to cut and paste, but to put the code that you want to call again into a function. Name that function something descriptive, and then instead of cutting and pasting the code in all these different places, just put a method call in. So this example on the slide is convert to pounds. So it does the conversion. If you send it an amount in kilograms, it returns an amount in pounds by multiplying it by 2.205. This is a complete function in Lua. So Lua uses the keyword function. You get to name it whatever you want, as long as whatever you want is a valid Lua identifier. So the rules we talked about last time apply. Letters, numbers, underscore are all good. No other symbols are good, and you cannot start with a number. Beyond that, it's up to you what you want to name it. You'll notice that there are parentheses after the name, and those are required. There is something inside the parentheses, which is essentially a variable that we'll use inside of the function to work with whatever you put in those parentheses when you call the function. So I call it kg here because the intention is when you're calling this, you're going to put an amount of kilograms in, and we'll use it inside of the function to do the math, and it makes sense to call it something descriptive. In terms of calling a function, like I said, you just call the name of the function. So if we have this function convert to pounds, we need to call it by using that name, having the parameters, and then since the function's expecting data, we want to pass it data. In this case, I'm adding together 2 kilogram amounts and passing that result as the parameter to convert to pounds. Convert to pounds does that math, multiplying that sum by 2.205 and then sending the result back. I capture that returned amount in a variable called pounds of DME using the assignment operator. So if this was a real program and we often had to do this conversion to pounds, it makes it a lot easier. And also, like I said, maybe at some point in the future we realize, well, we need a more accurate conversion. We need more decimal places on that. The recipe's not working out consistently, so we want to take it to 4 decimal places, or whatever the case may be. We want to make a change to that conversion function. We can just go in our code to that one line of code that does the multiplication and change it, and then everywhere in our code that we've called that function automatically will call the updated function. So you'll make it so much easier to keep your work up to date and in sync and correct. Okay, so switching gears a little bit to Solr 2D, because first off, I know this is a little bit confusing because we're essentially using 2 different languages, but we're using them together. We're using Lua as the basic scripting language and syntax, so we get a lot of stuff out of Lua. You know, Lua is what provides access to all the variables, data structures, the table. All of the operators are operators that are built into Lua. Built-in functions in different Lua libraries are available to us. And this is all done with Lua. We could write an entire program in Lua, and people do. It's a popular scripting language because it's free, it's easy. The thing about Lua, though, is it doesn't know anything about mobile devices. It doesn't know anything about how to get stuff on the screen. Lua by itself is a console-based scripting language that you cannot build a user interface, a graphical interface, I should say, in Lua. So everything we get to create phone apps, everything that we get to create the user interface on a phone app, to listen for what the user does, touching, tapping, building animations, transitions, physics engine, the physics engine and game-like physics, all of that we get from Solr 2D. Essentially, Solr 2D is a layer of tables and functions that sit on top of Lua. So we get everything that's in Lua when we use Solr 2D, and then we also get all of the features added by Solr 2D. That's our mobile app, then rests on everything. When I say Lua / Solr 2D, it's not trying to confuse you. I'm just saying it's this ecosystem of Solr 2D features that are built on top of Lua features, and we get all of it. All right, then drawing a code. Okay, so like I said, I've said a couple times, I wrote this little IDE initially to help students display objects on screen, to draw stuff on screen, because it's one of the first things that you learn in programming, because it emphasizes or helps you learn about the order that you do stuff in. When you draw stuff on screen, it gets drawn in the order that you draw it, which means that stuff you draw later gets drawn on top of or over stuff you drew earlier. And so some people struggle with the concept of doing stuff in order and how the order that they do it in affects the result that they see on screen. So and the result that in more complex programs, obviously, just the sequence that you do things in will drive the results that you get. So I started out with drawing a code just so that students could draw stuff on screen and then easily rearrange the order of the stuff that they were drawing in their stack. It also shows you what you'll see on screen as you make these changes. So essentially, all this other stuff is scope creep. I realized at some point that I could add additional stuff, and then I didn't stop. And I kept adding stuff and more stuff. So there is at this point 6 what I call palettes, although I don't know if that's the best word, that contain features that you can add to your app. So it's display objects, which is what we cover next, widgets, actions, physics, functions, and snippets. There obviously are more palettes that could be there, but this is what's there now. And so the script object is just a term I use to represent what it is that you add to your design. So when you add stuff in drawing a code, it'll show up in what I call the stack. And the stack, each item in the stack is a script object, which is a bundle of Lua code that performs some some task or does something for you. For example, the new text function that we talked about a couple slides ago. New text requires some information when you call it. So you see me calling it in this code on screen down towards the bottom where it says object2 equals display.newText, and I pass it object2 options, which is this entire table of key value pairs. This is a third syntax for tables, by the way. We talked about the other two syntaxes earlier. So Drawn to Code will write all this for you and allow you to visually do stuff like change the position, the size, the font, and the alignment using an easy settings panel. This would be an entire script object that you'd get generated for you when you add a text script object or text display object to your Drawn to Code stack. And then here's an example of the settings panel for text. So you have a lot of control, but the settings panel will be unique, obviously, for whatever you add. This is for a text display object. If you add, a circle, for example, then you're not going to get font settings because circles don't have fonts, right? So every different type of script object gets its own settings panel, and some of them are quite short, actually. This one's actually pretty long because of all the buttons and sliders that are necessary to give you control over that entire settings panel. If I want you to be able to change everything in here, then I have to provide a UI that lets you do that, graphically. All right, that is chapter 2, the overview, the helicopter tour. I hope coming out of this that you have a sense of sort of what programming, what building mobile apps using this entire framework is going to look like. I know that there are areas that can be confusing, and again, we're going to go over all of this in these subsequent, there's 12 more chapters. We'll spend some time in all of the chapters learning additional pieces, small steps at a time, to get you to the point where you're comfortable using all of this and can create mobile apps using lots of the features that are built into this framework. All right, I'm going to switch gears into the next chapter then and just talk about the screen and text for a little bit and how you get text on screen, and then we'll do a kind of a follow-along activity in Drawn to Code. All right. The purpose of this chapter is to talk about the screen on mobile devices and how we put stuff on the screen. And the running example in this chapter will be text. How do you add text to the screen? And so you might think, oh, wait a minute, I already did a hello world. I got the text hello world on screen. Well, you really didn't. We got hello world to show up at the console, at the device console. That's not something that you can see on a mobile device. The mobile device, you see stuff that you put on the screen. So that's the difference, is we're going to learn how to put stuff actually on the screen. To do that, you got to understand that mobile device screens are like desktop screens in that they use typically a rectangular shape of a certain number of pixels, and the pixels have a certain number that are width and a certain number that are height. The problem that we run into fairly quickly is that lots of devices have wildly different pixel widths and pixel heights. So I have a partial table here. There's a newer table in the book updated for some newer iPhone models. The problem is if I wanted to create a table that was actually all-encompassing, it would be huge and it would need constant updating. What I want you to see is that there is this variation. I mean, you can pick any two rows and you'll probably get two different pixel resolutions. But what you'll also see maybe is that there's some common shapes. There's some resolutions that are exact multiples of each other even. So as an example, at the top of the table, you'll see the iPhone up to the 3GS. So all of the original iPhones used a screen that was 320 pixels wide by 480 pixels tall, 320 by 480. And then with the introduction to the iPhone 4, they doubled that to 640 by 960. So that gave programmers a lot more room on the screen to do stuff, but it also made it easy to upscale programs, older programs. All you had to do was double their size, and you didn't have to make any sort of changes because all you've done is scaled up to a higher definition version of the same working space. Starting with the iPhone 5, the displays got stretched taller. So you can see that they went to 640 by 1136. And then after that, they just kept getting denser and denser, and they were not exact multiples anymore. So even if you wanted to stay in the iPhone ecosystem, you run into this issue of, well, how do I put stuff on screen so it stays in the same location for all of my devices? You know, if I want to put something on screen, I want it sized to take up a certain amount of the screen, maybe to fill the top half of the screen, or whatever you wanted to think about. It becomes more difficult to figure out how do I write my code so that it will do that for users of all these different devices, right? So just as a brief example, I created this little logo, Wands Are Us. It's 200 by 200 pixels. That's our logo for our store, Wands Are Us. It's going to look different on different devices. So on an original iPhone 4S, you can see it takes up a fair amount of space on the screen. Put it in the top left corner there, kind of close to the top left corner. And it comes over not quite to halfway across the screen and goes down, I don't know, a quarter of the way, a fifth of the way, something like that. But if we switch and run that exact same app on an iPhone 10, see how much smaller the logo looks. And to some extent, the physical size isn't the issue because the iPhone 10 was physically bigger. So you wouldn't actually have seen quite the disparity maybe, but just proportionally now the logo takes up, well, less than a quarter of the width, and now all of a sudden less than, an eighth of the height. So it's comparatively gotten much smaller. And then do the same thing, say, on an iPad Pro, and bam, now you've got, your logo taking up less than maybe an eighth of the width and a tenth of the height, something like that. So maybe that's what you want, maybe that's what you would expect, but in most cases, if we had an entire interface that fit on this iPhone 4S, we had buttons, we had text, we had stuff that looked beautiful on this. If we ran it on the iPhone Pro, it would only take up this amount of space. So you'd have the rest of it just completely empty, black. That's the issue that we need to figure out how to deal with. One way to deal with it would be just to simply scale your apps up and down. So instead of using literal pixel values to locate stuff, you'll create variables and scale those based on the device that you're running on. So you need to detect the device that you're running on, what its pixel resolution was, what its width and height were in pixels. It's totally doable. It would be a huge pain though. And also when new devices came out, all of a sudden you'd have to go and recode your app to support those devices. You'd just be stuck in this ever-running repetition of trying to keep your app looking okay as new devices came out. So there's problems. The solution, well, ideally the solution would be that the device just magically scaled your interface and made it look fine no matter what device it was on. The problem in practice is that's a little bit harder than it might seem. Solar 2D can scale your device using one of three different scaling approaches to try to make it look good on all the different devices. So to a large extent, we can avoid having to use variables to position everything. So instead we can still use, for instance, settings we might get from drawn to code when we drag stuff around exactly the way we want it. And then we can tell Corona or Solar 2D what kind of scaling system we want to use, and then it'll take care of that. And in general, make things look pretty good. The key to do that is that we don't code for a particular device. We code for what Solar 2D or Corona calls a content area. And the default content area most people use is 320 by 480, even though that's so old, because it doesn't matter. That gives you a space on screen to work, a working area. So we write our code with pixel values that are based on this content area. As an example, if I wanted to put something in the center of my device with a content width of 320 pixels, then I know that the center pixel is at 160 over. Likewise, the vertical center is 240 pixels down from the top. So all I do is I'll write the code for that virtual content area, and then Corona will take care of the rest, more or less. The config.lua is very short. It can get quite a lot longer, but a basic content Lua really just spells out the width and the height of the content area, and then the scaling approach that you want to use. So you can see here I've set it to 320 by 480 and used letterbox scaling, which I'll talk about on the next slide. The other thing to note is that Drona Code will write this for you. If you write an app or design an app and you save it into a project folder, Drona Code generates not only the main.lua source code file, but also a content area file and another file that's a default file for apps to run correctly. If you're not using Drona Code and you're coding by hand, you'll need to code one of these by hand. The good news is any app that you write that's based on this content area would use the same config.lua. So you can write it once, and then copy and paste it into new project folders. Okay, the scaling. So there's three modes: letterbox, zoom even, and zoom stretch. And what they do is illustrated in these three figures. Letterbox makes use of the screen's width or height, or the Solar 2D can scale your content up and hit the lower of those two values, the width or the height. So in this example, the content area has been stretched to the width, but the design doesn't include content that's above this gray box or below the gray box. So you would end up getting, in this example, black bar kind of at the top and the bottom of your code or your screen, which may seem bad. You may be looking at that and thinking, well, wow, I don't want to see a black bar. But remember, the device screen is black, so an empty area that's black doesn't necessarily stick out as something that's crazy weird. Also, in your Drona Code design, if you've made, for instance, a background gradient and you've extended it up past the content area, then you wouldn't see these black bars. You'd see whatever you'd put outside of the content area would show up, even though you've letterboxed it. Zoom even kind of does the same thing, except instead of leaving blank space, it cuts off space that would scale when scale will go over. So it allows one of your dimensions to overlay the content area so that it will be cut from what's on screen. So in the example here, you can see it's essentially trimming a little bit of area to the left and to the right. If you had stuff in that areas, if your buttons or your text or your visuals were right up against those left and right edges, then they would be cut slightly from what users saw on the phone. So if you're using Zoom Even, you would be really cautious about your edges and not putting stuff up directly against the edge in anticipation of some devices trimming it. And then Zoom Stretch. So Zoom Stretch looks almost perfect, doesn't it? It has scaled the content area to match the device screen perfectly. It's stretched it or squished it so that it fits exactly to the pixel. So lots of people would look at this and think, and you may be thinking this right now, Zoom Stretch looks awesome. Why not use Zoom Stretch? There's no black bars. There can't be black bars. There's no trimming because there's no need to trim because we've stretched it or squished it or whatever to exactly fit. Well, so the issue is, yes, zoom stretch will do that, and it may work okay for some UIs, but you got to remember then everything that you've drawn, every widget that you have, every image that you're displaying will get stretched or squished to fit. And so what happens more often than not is with zoom stretch is when you run it, you realize this looks terrible. My button's super skinny, or my image has stretched wider than I want, and now looks kind of fat. You know, that's not really what I wanted, especially if you spent a lot of time carefully positioning and sizing stuff to get something exactly right as you want it. When you use zoom stretch and you pick a device that requires it to be stretched and you see the result of the stretch, it doesn't look good. So the default for drawn to code is letterbox because that doesn't truncate any content. But you can go into the config.lua and change it to zoom even or zoom stretch and see what the result would be. That's easy to do. I don't know that I've seen a design where zoom stretch was the correct choice, the best choice, the best looking choice. Functionally, maybe it's the easiest because you don't have to worry about stuff getting truncated, and you're also using every pixel of the device screen. So I guess conceptually, I know the kind of app that zoom stretch would work well with. I just can't think of an example of that app. All right. I don't know why you wouldn't use config.lua. If you wanted to code stuff manually, though, you can get the displays content width and content height programmatically. You can also get the actual device's pixel width and height using a device detection script, and I've included one inside of drawn to code to be helpful. Fonts are an issue. The biggest issue is the same issue we have coding desktop apps, which is if I use a fancy font and the user doesn't have that fancy font, then what happens? If I use whatever, Helvetica, not Helvetica, Herculaneum, something really, really wild, and then deploy my app, and the user doesn't have that fancy font, then your text won't appear in the fancy font. And so that's where we'll pick up content topic-wise next time here, but let's switch to drawn to code. So what you're looking at in drawn to code is essentially a content area. This is meant to look like a mobile phone. The darker area represents a content area that's proportional with 320 by 480. Let's do a quick project and then save it and look at the config.lua and then do some stuff. So to add text to your drawn to code design, you just hit the text button. It's in the display objects palette, which is the default palette when drawn to code opens. And it's going to write all this code for you. I've got a chunk of just commentary at the top of all the generated code. You can turn that off if you don't want it. It adds some stuff which is instructional, and it also, once you save it, it will list the name of the saved file, which can be handy if you find your generated source code and can't remember what design generated it. It'll tell you in the comment area at the top of the code. As you make changes to the text, I mean, if I move it around, for instance, if you watch the X and Y location, it's updating live as I do it based on this content area. I'm going to change it to just a 0 because we're gonna change it programmatically in a minute and do something of a counter. And you can see over here in the generated code maybe that it's changed the text in the settings to 0 to match what I've typed here. I do have control over fonts. The default font for iOS devices is Helvetica New. You can change it in font settings. But again, the caution is I've got a lot of fonts on my computer. You probably have a ton on yours. this dialog shows you every font that's installed on the computer you're developing on. Just because it's listed here does not mean it's on the device. It just means that you have these installed on your computer. So this is where you want to be careful. iOS actually has a pretty decent set of default installed fonts. In any event, we have total control here. All I'm going to do, I'm going to crank up the size quite a bit. And if you follow along, what you'll notice is now things look a little awkward in Drawn to Code. There's two boxes. The red box is essentially the content area for the text as you've defined it. It's got the XY location and the width and the height as you gave it. But now you made the font so big, it doesn't fit in the content area for the text. So all you need to do is change the height to match the font setting. And once you do that, the red and the teal warning boxes go away. So I want to hit the save button to save my Drawn to Code design. I'll get a Java file save dialog box. So I want to find wherever my work is. So on your computer, if you've already started, working on some of the homework, I've already coded, you coded the Hello World app for sure. You probably already have a folder that is for your work. I haven't done that this semester because I haven't coded anything in earnest yet. I'm going to create something, and I want it ideally to sort up at the top to the top of this so that I can select it super easily. I want to create a new folder. I want to hit the new folder button, and then I want to type in something descriptive. But in my case, I really also badly want it to sort at the top here so that I don't have to scroll. And then again, we probably want a folder for every chapter. So this is chapter 3. Is it chapter 3? I think it's chapter 3. Yes. Okay. And then again, because every Solar 2D app, the script file that's generated has to be called main.lua, you want to be careful about putting your designs in unique folders and naming the folders something meaningful. That said, if you name all your Drawn to Code designs differently, you can just load the design and regenerate the main.lua that you're interested in. But at the very least, probably you'll want to have your work divided up between chapters. So then I get to name the design, and so I'm just going to call this a text count. This is just a file name. So you can have spaces and symbols. Anything on your file system that works as a file name will work here. It saves your Drawn to Code design in the folder that you specified. So you can see I've got one mobile designs, chapter 3, and then text_count.d2c. What you'll run is this main.lua that's generated automatically by Drawn to Code. Well, so now we can run it. So if you want to run it, hit the run button. That should launch the Corona simulator. Nothing super exciting, right? It's whatever device you've selected with a 0 in the middle of it. Now let's peek in this folder where the design is. So you can navigate to it, in Windows or the Mac if you want to, or I have an option in the file menu that's Show Design File in Project Folder. So you can hit that, and it will launch a Finder window, an Explorer window located at where we're doing the work, which is a useful time saver for me frequently. So you can see now there's 4 files here. There's text_count.d2c, that's the Drawn to Code design. There's main.lua, which is the script file with this contents. And then there's the 2 settings files I mentioned, config.lua and build.settings. If you peek at config.lua, you'll see it is exactly pretty much what we talked about. That's a file that you could edit now. You could change letterbox to one or the other, zoom even or zoom stretch, to get these different effects. If you deleted the config.lua, it's going to change what appears on the device if the device's screen resolution is different from a default 320 by 480 design. So what you would see if I delete config.lua, if you want to do that on your computer, it's fine to do. As soon as we save our drawn to code design again, it will regenerate any missing files. So don't panic over that unless you had done a lot of heavy editing by hand in config.lua. Drawn to code won't duplicate that. If you did that, or if you're watching, what you'll see is the 0 now is no longer in the center, it's up here in the corner, because this phone screen is double the resolution, the default resolution we're using in our code. So essentially we're using, like a quarter of the screen, and that's why the 0 is up here in the top left. Okay, let me save. I'll show you if I can. As we save the design, config.lua is missing, and now, like magic, it's not missing. Okay, so let's just do a little something with some of the math operators that we've learned. So what we'd like to do is count the number of times the user taps on the 0. So it's conceptually really easy. What we should get is a screen that starts out with the 0, but then when you tap it with your mouse, or if you have a touch screen with your finger, it'll count up one by one. So we want to select the 0. I'm going to scroll down and hit the Add Listener button. So in the settings panel for Object 1, if you scroll down, you should see a button that says Add Listener. We're going to add the tap listener, which is the default listener. And let's save it and run it. So if you're following along, you should get the same, it looks like the same app we just had. But if you tap the 0, you should get information down here in the console that describes the tap. So what Drawn to Code has done is it's written, Drawn to Code's done the work necessary to hook 0 up, or this text object, object 1 up to the tap listener. It's written a function for you called object 1 tap handler. Inside of object 1 tap handler, the code that's in that snippet runs every time a tap occurs. So if we want to count instead of just describe the tap, we need two things. We need to create a variable to store the counter, and then we need to edit that default snippet or add a snippet inside there with the code that does the counting and the updating. It's actually super easy to do. To add variables, you'll want to go to the snippets palette and hit New Snippet, which is at the bottom. That creates a little bit of code. In a snippet. It's object 4. It is empty. And this is where we can add whatever we want to add by hand. Any variable we create in the snippet, let's create the variable, sorry. I'll talk about flow of execution in a second. So I'm just going to name it app variables so that it, except I misspelled it, so that in the stack it shows up as what it is. And then I'm going to say, sorry, let me do this and zoom in so that you can see. I want to create a variable to do this counting. It has to be a valid Lua identifier. I'm just going to call it count, and I'm going to try to set it to 0. So that is variable declaration and assignment in Lua like we just covered on Thursday. Just as a Drawn to Code usability thing, I have these little buttons that essentially break out certain content so that I can zoom in easily when we're talking about it. And also, if the snippet gets long, I can size it to give me a much larger area to work in than the relatively small box here. To make the blown out content go back, there's a button here to make it go back. So you blow it out using the out button, and you stick it back in using the in button. Okay, now we need to edit the snippet. That's the snippet I want to edit. It's inside of this tap handler function that was written for us. Here's the default snippet. This is the code that generates that little bit of information out at the console that you just saw. You remember it talked about a tap had occurred on what object. It gave you the XY coordinates of the tap, and in case there was a double tap or a triple tap, it will tell you whether it was a double or triple tap as well. It doesn't do any counting, so if we want to count, we want to add that as a bit of code. In this case, I want to increment the counter. Count equals count plus 1. So that uses the assignment operator again and the plus operator, which is a math operator. So in terms of flow of execution, the right-hand side is evaluated first. Remember, the math is done, and then the result of the math, the result of this expression, is then assigned into the variable. In this case, we're assigning the result into the variable itself, so we're replacing the old count with the new count, is what this syntax does. And we could now, if we wanted to, take a peek at the number using a print statement. So just like we had done with hello world, instead of printing hello world, let's print count. That should display that number to the console, but let's double check and make sure that it does. So you should see, if you do this, hopefully at your console, the numbers counting up. Do you see them? All right. Okay, so we're 90% of the way there. All we want to do now is update what's on screen. So heading back to drawing a code, looking at the snippet again, I want to change the value of this object to change its text. So to do that, I need to know what the object ID is. I could look in the stack and see that it's object 1, or I can hover over it in drawing a code and see that it's object 1. Either way, it's object 1. So to update object 1, I'm going to use the syntax object 1. Object 1 technically is a table, so this is using the table dot syntax. So object 1 dot, the attribute I want to change is called text. So object.text equals count. So in terms of how this is processed, the right-hand side is processed first. In this case, there's no expression. It's just a variable. So Lua/Solar2D looks up the current value of count and places that here as the result. And then the assignment operator takes over and puts that into the text attribute of object 1. If we save it and run it, we should see tapping changing the number. All right, so that's a basic example that shows you how to get stuff on screen, how to get text on screen, how to put code inside of a function that's been written for you by editing a snippet that's inside the function, how to create app-level variables by creating a snippet outside of any function, and then also how to do basic math and how to assign the result into an on-screen object. This is where I want to stop, so if you don't have any questions, this concludes the content I wanted to get to and the activity I wanted to do.